We're going to start permutation and combination flow soon, and after we go through some counting principles. But before we go into the main dish, so then we have a new notation to talk about called factorial. Factorial, we use the symbol exclamation mark to help us call n factorial here. So what does that mean is simply means that you are multiplying from 1 to up to n. For example, 5 factorial means 1 times 2 times 3 times 4 times 5, which is okay, let's wait, which is equal to 120. And then by definition, there is a special case where 0 factorial is defined as 1, so as for the result. And now you can try to use your calculator to get the result of A, B, C, D, E, F, so by yourselves. And then coming up next, factorial will be a new operation to you, and then so that's why some rules may not be okay. What I mean is, example 12 want to tell you the factorial cannot be broken down in the addition. So for example, when you want to say, can I put A factorial, B factorial together to be A plus B together factorial? Is it possible? If you want to argue with it, so it would be good to see whether a particular example works or not work. When it's not work, that means it's no longer a formula because it's wrong for particular numbers. For example, like 3 factorial, 5 factorial, by using a calculator, you can check where is the factorial are by yourselves, and then so which is 6, 120, which is 126. Okay, but now coming to part B, you want to check can I add up first and taking factorial afterward. But in this case, it becomes 8 factorial, which from calculator give you 40320. So now you will see that it's not equal to 126. What does that mean? That means after checking one example, it doesn't work. That means generally speaking, you can't say A factorial plus B factorial is A plus B together factorial. So it's wrong. And then now you also have 2 very quick exercise on working on factorial by yourselves. So please try them out by yourselves. And then now we start having permutation first. Permutation is talking about arrangement of a set of objects with definite order. So what do you mean by definite order? That means, just simply call it with order. Because later on we will be talking about combination, which is mentioning about without order. One simple example would be, for example, there are 30 students in your class. I want to pick 3 of you to bear some posts. For example, president, vice president, and also treasurer. So that's why student 1, student 2, student 3, if I put it in this order, it's different to student 2, student 3, student 1 here, because the order, if I put student 1, 2, 3, they are different because we have post, president, vice president, treasurer over there. So it makes a difference. So this is called with a definite order with order permutation. But in other case, I'm just want to find 3 students S1 to S1, S2, S3 to help me to make a board, for example. If I reorder them, call S1, 2, 3, S2, 1, 3, actually there is no difference because it's still these 3 students helping me. It's no difference. So this is called combination. We'll come to take a look on the more details about permutation and combination afterward. And then in permutation, the definition is quite terrible because it's using factorial. So what does that mean is, for example, if you want to calculate like 5C2 in the by definition, so it's called 5 factorial on top, 5 minus out, that means 5 minus 2 factorial, and then 5 factorial, 3 factorial, and 5 factorial means 1, 2, 3, 4, 5. Okay, 3 factorial means 1, 2, 3. So the last is 4 and 5 left and equal 20. That's terrible, right? So as a result, you may use calculator to find out how we find NPL by using calculator. Now you take out your calculator and check in the multiplication sign. So there's a symbol of not C. It should be MPR. So that's why how we find part A, 6P2 in calculator will be we enter 6 first, then shift, multiplication sign, and then 2, and you have EXE. And so let's see whether you obtain the answer, which is 30. If it's alright, then please try out B, C, D by yourself in a minute. Okay, so please check your answer. Part B will be 1680, C will be 6, and D will be 1. Okay, so now we move on and take a look on how we use MPR to help during finding the answers in accounting problems. In example 15, you're asking how many different ways that you can form a 3-digit number from 1 to 3, 4, 5 without repetition. So you can repeatedly use the numbers by yourselves. How it will be working? A 3-digit number, there is an order. 1, 2, 3, 3, 2, 1, there are 2 different numbers, so the order is important. And then so how we write the answer will be among 5 numbers, 1, 2, 3, 4, 5, you pick 3 of them to make the number. So that's why by calculator you've got 60. That is easy, right? Similarly, example 16, you are choosing from 7 numbers to make a 4-digit number. By calculator is 840. So this is the use of permutation, where you're talking about question with order. Now you may have a question, wow, then what was the difference between MPR and the method we have before? Somehow you may say they're the same, but it's just a difference of the presentation. If you like to use the previous method, then 3-digit number means you have 3 boxes. First number, so you have 5 choices. Next number 4, next number 3. So that's why your answer will be presented as 5 times 4 times 3, which is a 60. Similarly, you have 1, 2, 3, 4, 4 boxes. For 4-digit number is number 16. Then the number of choices will be 7, 6, 5, 4 in this case. So that's why 7, 6, 5, 4, which gives you 840 as well. In this situation, then, so you find that MPR and multiplication rule may help to do the same question. But there are pros and cons. In presentation, you will see that now MPR is easier. But in some occasions, that MPR may not work somehow. For example, do you still remember when you set a password? For example, in your luggage case, 3-digit number. In this case, each box will be there are 10 choices from number 0 to 9, 10 choices and 10 choices respectively. Then you have 10 times 10 times 10. The situation is the number can be repeated. For example, you can set password 111 or 223, for example. When the numbers are allowed to repeatedly use, then MPR cannot work in this situation. So that's why, generally speaking, I like the second method because it's more universal in dealing with the problems. Next, you have 2 more examples, and let's take a look in example 17 and example 18. I may be leaving for you to do it by yourselves. Example 17 tells you that 5 different numbers. You want to make a 5-digit number without repetition, so it's a piece of cake. I think I left it for you. But now, when you're talking about you want the numbers to be even, I think it's a bit different. Because if it's even, that means it may be ending at 2 or 4. So that's why I will be considering the question in this case. So it may be 2 at the end. It may be 4 at the end. So that's why in this situation, then you have 2 choices of even number with 2 at the end or 4. Now let's see the situation one by one. You have used the 2 already, so that's why there are only 4 numbers to choose from for the first digit, followed by 3, 2, and 1. So that's why it's 4 times 3 times 2 times 1. Totally, you can check, it's 24 possibilities. If you're still puzzling about this 4, that means this 4 means besides the 2 which is used up, then you still have 4, 5, 7, and 9. These 4 numbers to choose from. Similarly, this one you can still have 2, 5, 7, 9, 4 numbers to choose from. So that's why it's 4, 3, 2, and 1. 4, 3, 2, 1. So that's why totally there are how many ways you still have? There are still 48 ways to make an even number. This is the case. Maybe I give you one more example which is a bit weird but yet common that you may find in the MC exercise, which is maybe I make it simple. You can use 0, 1, 2, 3, 4, 5 numbers to make a 3-digit number. 3-digit number, okay? 3-digit number. In this case, it's a bit challenging because you have a 0 at first. So what's the difference of the answer would be this one you don't have 5 choices because the 0 cannot be used as the first digit as you are finding a 3-digit number. So instead you can only have 4 choices here. So because 0, 0 the number is not allowed. So 4 choices. But after that, after you use a number, maybe 1, 2, 3, 4, the second digit you can allow 0 to fill up. So that's why there are still 4 choices over there. And after you use this to fill up the 2 boxes, then you have the last digit, which you have 3 choices. So that's why 4, 4, 16, and 3, and finally there are still 48 choices over there.